Hello everybody. Hope you guys are doing well. So we will be continuing with our journey with Swift. So today we will be learning about closures. Now this is a very important topic in Swift. Mostly like we will be using these closures a lot. By mean a lot, I really mean a lot. Now closures. So now we have met integer strings, doubles, floats, booleans, arrays, and classes so far. But this another type of data is extensively used in Swift. It's called as a closure. These are complicated, but they are powerful and expressive that they can use pervasively in Swift. So you won't get far without understanding them. A closure can be thought of a variable that holds a code. So when we an integer holds 0 or 500, a closure holds lines of source code. Closure can also capture the environment where they are created, means that they take a copy of values that are inside them. You need to design your own closures, so don't be afraid if you do find the following quite complicated. However, Apple's framework will often ask you to write closures to match their needs, so you at least find. Okay, so what he's trying to say is, okay, yes. Okay, so closures. So closures are basically, they are basically variables that has a function. No, basically it can be thought of a variable that holds lines of code. So basically, there should be lines of code. For example, func lines, and then let's. So this works. The reason we can do this is functions are first class citizens. Now say here we are getting somewhere it says insert expected initial value after equal to. Okay, now let's see. A button is one of the many user interfaces controls that we have in SwiftUI. We provide something that can use that the user can be press on to basically it is lines of code, so you can call this as a closure. This is one. Oh, say now this is owning certain lines. So when I do what does this print? First time Xcode will take time. Let's give it 2-3 minutes. This happens a lot with Xcode. Whenever you run it for the first time, it takes few seconds to launch. Just until that time. Yeah. So let's open AI ChatGPT. So remember now this is a function. So closures are variables that hold code. Yes, closures are which captures and remembers the environment in which it was created. Okay, in Swift, this refers to a block of code. So curly braces are basically used to define a block of code. Okay. The button is one of the many that we use in SwiftUI. In this code, creating a button takes two parameters, some text to value as the button's title and a closure containing the code to be executed when the button is pressed. I specified press me. Let's open any Xcode project. Oh no, this is playgrounds, right? Fine, open. Let's no, fine, new. Empty file. Yeah. Oh no, this is not we want playground, right? We want new an Xcode project. Let's see where we have close page setup, find folder. Let's say open. Then this world. Let's see, it's not. I might have deleted workspace. Oh yeah. No. Let's cancel. Let's close. Why is Xcode still open? Xcode. Oh yeah, no, it's not new project. Let's make sure this is Swift UI interfaces. Create and then find new playground. Let's open this. No playground. This is the. Okay, now let's see. Okay, now button. So let's get rid of the this tag. Let's have a okay button, and then this is the basic one. So I have a text and then a function. So this is a function. Now yeah, define the function here itself. So I'm going to do print and then message. So when I click this, let's use something else. Why is iPhone? Okay, let's build iPhones. No, do we have something else? I don't want it to be, but this action will be visible. No, not this. Okay, let's select Mac. It's going to iPhone. Any iOS device. Son of press. Let's go see this. Builds. Replace. Let's refresh. Replace. Oh yeah, no, the build is succeeded. No, just let's wait. Just wait, it takes time. Let's see. No, not that. The button is one of the menu we use. Okay. So when see your message is getting locked, right? That action is getting so. Button is one of the menus. Okay, this is called creating a button. Some text as shown is the button's title and a closure containing the code. I've specified press me. Okay. The above code also shows how closures capture the environment. I intentionally declared the message constants outside of the closure. Oh, for example, okay, so now what he's trying to say is, let's have a, not in this. Let's declare it outside. So this is, let's message, let's just view type string equal to, now instead of, okay, never used, right? So now what I'm going to do is here try to have that message being used. Okay, now just replace the build debug again, build successful. See, now what is happening is message, but this is going, is it capturing the scope? Let's say this is closure. Place will succeed. Okay, so now although this message variable is declared outside, right, it is still getting captured. The above message also is that I intentionally declare the message outside of the function. Swift detects this and makes the data available inside the closure too. So system of automating capturing a closures environment is very helpful, but can occasionally trip you if a object A stores a closure as a property, and that property also reference object A, you have something called as a retain cycle, and you will have NAP users. This is a substantially more advanced topic than you need. Okay, so now what he's saying is let's okay, attachability closure insert retains an environment by Swift capture the values from surrounding when it's created capture exception. It means if variables declared outside inside. Yes, exactly. Okay, so now let's open playground and see something. Playground, yeah. So remember, if this is a function and variables, right? Okay, now this is empty, return this one. Now if I need to access any variable inside this, it should be declared inside the scope. For example, if I try that message is this is scoping print and then long slash. Now let's run. to this. Let's run it. Oh, make a call. Look at this. 3, 2, 1. Let's see. Here, and then that. Let's really balance and print. This is variable scoping control as variables. And now let us declare okay, closures is outside, right? And then let's do slash. Cannot find. This is variables. Cannot. Oh yeah. Wait. We'll see that. That is name. And now I do closure. Closures. Let's this be something like J when this out. Okay. Now see the main actor closure. What's this? Now ideally, since this variable is not inside this, we should get an error. Cannot be referenced from an non-isolated show. So where declared control C control. Now see. Now let's run. B is not defined. Let's run. Okay. Now where closures? Now what is happening is, since this is declared outside the function, it's not able to get it. So then we are getting an error over here. So what we should do is, so this can recognize anything only which is inside this scope, like inside the parentheses of the function. So now when we should run and say this is scoping and I got J. Let's see it diagrammatically what's happening. Okay, minimize. So there is a function. No, this we can access. We only have access to elements written inside can only be accessed when we call this is called as local scope. So every time a local scope is generated. But now what closures do is Now see in this, now in case of I declared a button, this is text, this is a function, right? And then now I'm declaring now this ideally we shouldn't be able to access this given here, but because closes and screenshot is made of the screenshot gets the I mean the scope is captured like a screenshot. That's what he's trying to say. Yes, exactly. If variable is clear outside of closure, the closure can capture and retain the variable, meaning it members. So now let's see what is the difference between a closure and a function. Function only has local scope, right? Okay, so closures and functions are both type of level contained for. Okay, now let's now here there is some now the next question we would ask is how do I identify if it is a function or closure. Let's see functions. So whenever we are declaring a function, we will use the func keyword to declare a function. Okay. Now closures are anonymous unnamed blocks that can be assigned to variables, passed as argument, functions, or returned from a function. Closures are reprint more shorthand. Okay. Okay, now then close. So when we use a closure, first is no fun keyword. All would always parentheses indicating lines of code. Okay, that's good. Now closures are anonymous and can be defined in line, which makes especially useful. By anonymous is okay. Now there is a relation between how to convert a function to a closure. So if we say let's see first what are anonymous a function without a name is a function now without a name is okay. Okay, let's see anonymous. So these are functions without name. Okay, Now syntax is you have parameters. This is here you write return type, then your parentheses. Okay, and then so there are two ways, right? One is okay, yeah, and then in. So this parameter will contain types, like which type is being passed. This is type of value being passed, and then anything after in is function body, and here we can, this is parameter passed in here. Okay, short and closer syntax is, there is one more syntax. If is no return, just suit allows more closures more succinctly when the context makes the type obvious. For example, you don't have to actually declare the types or even use the return keyword if the closure. Okay, returns, then it's not like the normal function, but so remember, if there is an anonymous functions, then it is a closure. So can I say anonymous functions are closures? Yes, so anonymous functions are called as closures. Named closure, a regular function, but with a defined name. Let's say, but then we say, then when func is used, scope is not retained. Why? Great. The functions do not capture values by default. So to capture a value, we need to use a closure. Closure can remember values from scope in which they are defined, even if that scope goes out of existence. Yes. So wherever we are defined, remember closure. Closure. So I can say scope of contains capture where it is defined. Even the value is modified later. Okay. Function of the parameters. Functions are more static, stateless. They do not remember anything. When does a function capture? A function can capture a value if you pass it as a closure or assign it to a. So now I can convert a function to a closure. So when you pass a function to a function, so the other function behaves like a, so yeah, a function can behave like a, if it's assigned to a, if it's passed as a closure or assign it to variable, it becomes a function closure and it can be used. Okay, so there is one more method of converting function to a closure. So let's just assigning it to a pass it as a closure. Okay, let's check this example. What are you saying here? Okay, so now this is a function, right? Operand value, I assign it to this and then pass it. So calling the function closure. The functions that so okay, so let's see type of closures. Still locked out. A nested function is a function inside the function. Nested functions are closures that capture the values from the surrounding scope. Okay. A global functions, a function keyword is essential. A global function is a closure with a name. It's a closure that's defined in Swift. Closures can take several forms, each of different syntax. The core is closure is a self-contained block that can be passed around and executed. However, closures are global functions. Global functions a closure with a name. It is a closure that defined. But then this is a function, right? This is a global function. It's also a closure because it encapsulates encapsulates a block of code. Nested functions. So anonymous. Okay. Types of closures when they capture values. Okay, in Swift, because when they are created, this is the key. But then the thing is, remember this is going to return a function. This is a so global functions, nested function, anonymous closures with names often used inline, trailing, escaping, non-escaping, auto closing, capture. Closures are return time. Functions that example. Okay, when we make the function anonymous or assign to a variable, where does it behave like a closure? When we make a function anonymous or assign it, it behaves like because fundamentally both of these constructs are closures. Instead, functions are actually a type of closures. Specifically, a function is a named closure. A closure is a self-contained block that can be passed around and executed later. When you assign, but when we use a scope is not captured, right? But I'm certainly right. When we define a function, the scope of the function is not captured by default. This is an important distinction between functions and closures. Oh, so by default they won't capture because they are stateless, modular. Closures, on the other hand, variables from its surrounding environment where it is created. This means when a closure is defined inside the scope, such as inside a function or a block of code, it can remember. So closure is basically a function which has no name. You're on the right track. At a higher level, we could say a closure is a function without a name, but there's more than that. The key distinction is between a regular function. Also, the closures can capture values from the surrounding, which makes them flexible in certain situations. A closure is a certain blocks of code which can be passed around and executed later. Example of a named function, anonymous closure. Closure can capture the values of the way, like where they are decided. So I say set timeout closure in JavaScript. What's that? Okay, how a set time works with closures. Now a set timeout is a callback function, but now why is it capturing the scope? Okay, remember this is an anonymous. This is anonymous, right? So it will retain the scope. Because the timeout has an anonymous function passed, hence the scope is retained. Is that true? Exactly. The reason I said timeout works with closures and retains it accepts an anonymous function as a closure. Anonymous function. Okay. So basically a closure is an anonymous function. You just need to make sure. Just I don't. Let's adjust this. This is auto page. Yeah. So basically, closures are something. Closures basically means how to resize this. Oh, here we go. Let's put this. So, as I said, what is a closure is basically an anonymous function, or to identify if a function is a closure. So, what's the difference when we will say if it's a anonymous function, then we can say it's a closure. We will retain the outside scope. If it's having the func keyword, then it will not retain, and the scope is limited to where it is defined. Okay, that's good. Now where we will be seeing this in action. Let's okay, now there is something called as trailing zero. Trailing zero, this is like a special case. I believe this is a special case. Let's close this. I'll come down. Trailing zeros. A closure is used so frequently, Swift can apply a little syntactic sugar to make your code more easier. The rule is, if the last parameter to a method are closures, you can eliminate those parameters and instance provide them as a block of code inside braces. For example, we will convert the previous code to this. Button, press me. Okay, so what is the previous code? Okay, now remember these are. So instead of what we can do, Swift can apply later syntactic sugar to make a code easier. The rule is, if the last parameter to our method are closures, you can eliminate those and instead provide them as a block of code inside braces. Okay, so when by what is meaning is, instead of writing inside the uh, parentheses, just declare a block outside. Is that okay? Now let's see what is trailing zero. Yeah. So intro writing closure inside the parameter list. This move it outside. So let's see example. This is button, then this is press me, and then this is action. You have let's this is the let's get this is the closure, right? Last parameter. So what we would do is button, and let this be inside and move this part. Okay, this is what we have changed it to. The slide of parentheses, then the action that we want to take. When is going, so for example, let's see now button label syntax. This is going to be something that is crazy. So remove this. I do button. Let's search for button label. It should be a button shift and R. So I do oh wait, I got it. Okay, so now remember this is button. Now the first is an optional, second is an action, third is also okay. So now what's going to happen here? This is on, right? Okay, perfect. So then what happened? Delete button, where's the label? Yeah, so this is button, this is first is this is button row, and this is an optional. So an optional, then I have action. This is going to be a function, and another parameter is another parameter is label, right? So okay, now last parameter, the function closure. So have this thing here, so I can say this is func. So when I do this, so now what's left? So now I have button, then I have row, button, sorry, optional, and then action. Okay, and remember label is outside, label, and this is, so now this is last, so move this as well. So what will happen is I'll have button, then this is for action, and then label, which is for this comes out. So let's Either you can define it inside only. So then if we say over here, if we don't want to use, I say print. Oh, this has to be a label, right? I do text, and then I do press me, I go here, a function, and when I click on it, it should print message. Let's refresh the view. Syntax. Where is the syntax? Before continuing, where is the syntax? Oh, it's assuming this button roll optional. That's what is this parameter one? It's an option and cannot convert type button.type to expected argument type. So what is this value that should be passed? Let's see on OpenAI. What does this say? Does this yeah, this is machine. Let's do copy. It's an optional, right? As this. So what can we do? What could be that? Should we make it default? Oh, let's roll. We can do dot. Let's do this. Now does it work? This variable is not used. Okay. Or you can. Let's build succeeded. You go here. Waiting for a simulator to start. Come on. Okay. See, when I click this, the text message is getting printed into the editor, right? That's what we wanted. So okay, now let's come down. The protocols. Now what do is the protocols are so now we have heard about object-oriented language. Now we are going to study with protocol-oriented language. The thing is, protocols are going to be just basically they define a set of methods and properties that must be implemented. So then there is some let's say the difference between protocol-oriented versus object. There's going to be some differences between them. Let's see. Okay, now see when we study about OOP, remember it will be like the class based in the class objects and reference, right? So in POP, it's everything is lightweight. There is no class or something like that is going to deform. So think that the way we say is you just have a set of rules, and when whatever structure is going to conform the protocol, all the method inside that should be implemented. The conforming class should the conforming struct should implement that. So if this is a protocol and I have so protocols are effectively contracts like interfaces, but then in that we still need to do the object reference thing. Here it's all lightweight. This contract gives us the flexibility to use the same problem whether we got a thing or so you write it in a protocol. Now the first properties are get set after them. This means the conforming types should implement both. It should be both gettable and readable. So whatever is written over here, right, and whatever properties are mentioned, all the class which is going to conform to this protocol So we say protocols are basically a set of rules. So like interfaces are a set of rules which the implementing class will have to implement. So on similar lines, we have something called as protocols. Now what's the advantage of using protocols? Now we can, depending upon how we want to use them, the implementing class can monitor it. Then we have extensions. Now extensions let us modify such data type to add a new functionality. Why do we need an extension here? For example, we can have a my int. It's like extending, but let's this is very important, right? Then similarly we can extend protocols as well. But then what is an extension? Our major task is to understand that. Okay. Yeah. Let's see. Extensions. What are extensions? So extensions are, you can add, what does it say? Now it says extension in Swift allows you to add functionality to existing classes, structs or enums or protocols without modifying the original code. So if when we have declared a struct, for example, we have a struct where that has 3 properties, right? Now if you want to, there should be some behavior using which, without changing that original struct, using extension we can just modify it. So then we do something, then we extend it. Okay, so we do, for example, what he has done here is extending the int. So I have a string, is adding additional functionality. So this is a struct, right? Now I'm going to extend, and then this is what, so I'm going to initialize this to x dot y with different knock. Okay, now they can also make to be conformed to a protocol. Then you want to extend functionality in a specific without modifying the original type. So now whenever something is going to conform to a protocol, that specific method needs to be implemented, right? So then I need this thing to be implemented inside. So then this function is defined over here. Okay, so basically extensions are going to add extend, as they mean extend, they're going to add additional features. Yes, subscript. They are also adding, now limitations is we cannot add stored properties of you cannot add stored properties to types through extensions. You can only add so if it's a, so there are certain limitations as well when to use extension. So if it's a stored property, we cannot add stored properties to types through extensions. You can only add computed, so we can only add computed properties, we cannot add stored properties. Oh, for example, this is not a, this is, so if you want to extend, then this has to be some sort of getter setter or some computation. Directly you cannot have it. That's what he's trying to say, or have it inside a function. Yeah, these are all. Okay, so let's see, we are going to have a struct and make it have a additional okay, section is to modify Swift's data types to add new functionality. It can be, data types are basically types of values, right? A variable can be, struct is also a data type, right? But then the type, it's called class type. Yeah, now extend it. But by what do you mean by Swift data types? It's correct, right? Extensions such as classes, anything. The actual definition won't be modified. That's what it's trying to say. Let's use a struct on. Let's use a extension on a function on a struct. On a struct. Remember this might happen. So for example, add methods. Now when see the way I'm going to call this is okay. Let's see what's up. Let's go to playground. I would say playground is a. Is this open? Okay. Let's have all of this bad. Now I say it closes. Now let's talk about. So using extend. Using without modifying the original behavior. The original behavior will remain as it is. There is no effect on that. So you come declare a struct rectangle. This is a structure of type rectangle. I have two properties where length alien this and let this be int type and then I have where height. So I say height. Let this also be int. So now let's create rectangle reference and then let's create an instance. So I do a rectangle length, then make this. So right now there is, if I see any methods in here, right, so there are none, like except the type and self and init, which is the initializer, right, the default one. There are no other methods. Now what we will do is we will try to extend. So then use extend extension and then what are we extending? Sorry, rectangle structure. Now this is a type of rectangle, right? This struct is a type of rectangle. So right over here. And then now let's add some functions. I say func area. This is an empty. This returns nothing. And then just we're going to print length into height. Say length. Okay, so now this has to be this has to be backslash length into height. Is it length? Okay. Now see, now when we come and use the rectangle, now see, now when I put a dot, now see, cannot find type rectangle and scope. Oh, it's GL. Let's make this L. GL D, and then okay, so reference dot. See, now we have area. So what we have done is this is Let's not write this way. Keep it this way. Now this is cannot find length. Oh, something else got deleted. So let's just be where length. Now if we run inheritance from non-protocol type, what's happening here? Oh, let's remove this. Let's run this now. Now my playground inheritance from non-protocol type int. There is let's. Why did I mention? That's wrong, right? Yeah, so now I'm getting area as 100 because 10 into 10, 100. This is good. Okay. Then why should we extend? Why should we? So like some basic, the thing is, suppose if you want some extra features for something, but not for all. But protocol inheritance, if you confirm to a protocol, then all of the conforming types will have to implement it. That's the reason. Then so, and you can use the extensions. When all like some type wants that, maybe like that. Yes, that's what. Oh no, let's see now what I'm saying. I have a protocol function draw, function erase, so the drawable, but then whatever is the type that is going to confirm, we'll have to do that thing. Where is our drawable? We were in drawable. Let's go up. Maybe come here though. Oh, this is the exam. Come. So let's see. Now this is, so what? Okay, so that's not drawable. Now whatever class is going to confirm, for example, so is this is a, okay, so now whatever is, if suppose if this drawable is here, whatever class is going to confirm this has to implement this. But what is this? Okay, but what if now say he has done extension to a drawable, and then we don't want that thing to become in all methods. So how is he doing that? Circle, square, I have a radius, side length, okay, extension drawable, here is, I have a circle, drawable, radius, double. Okay, so then I'm saying conforming to this protocol, I'm going to implement draw and erase both. What is only implementing erase? Oh, so the extension has already given like a default implementation. Let's say. This is very saying it's where there is a default implementation that the conforming types don't have to implement themselves. So in extensions we'll be using to extend protocols when we have like a default implementation and all the conforming types should not implement that default behavior. So extensions are used. So protocols are extended. What is trying to say is protocol is done when all the conforming the protocol method, like it's something like a default method for all. More like a default function for all. And remember, for computed types, whenever there is some there is some uh there is some what you said is there is some limitations to extensions, and that limitation is this extension should be okay. So we cannot directly mention something. There's a limitation. Wait, where I was limitations on extensions. Oh yeah. Okay, let's limitation on extensions. Okay, so we cannot add stored properties. If you want to add a property, then it should be a computed one. And then so there is overriding of existing methods is not possible. And we cannot add the initializers, cannot add or modify initializers for structs. Remember, cannot modify stored properties. If it's a stored property, cannot add or change property observers, something that is going to happen when that state of the property changes, right? So whenever we have will set, and will set has access to the new value, do set has access to the old value. Okay, that's, and cannot add subscript or operators. Okay, that's all from my side. See you in the next one, guys. Thanks. Bye. Take care.